Here we are trying to find out the solution of a system of linear equation using simplex method, right? And the given system of linear equation is given by x1 plus x2, this is equal to 1, and 2x1 plus x2, this is equal to 4. And before solving this system, we cannot say about the value of the variable. Okay, so the value of the variable, that is x1 and x2, may be greater than 0, may be less than 0, and may be equal to 0. Okay, so we say that the variables are unrestricted. Unrestricted in sign in view of simplex method or from the point of view of linear programming problem. Okay, and so restricted this variable, we replace this variable x1 is equal to x1 dash minus x1 double dash. Okay, and we replace x2, this is equal to x2 dash minus x2 double dash. Okay, then x1 dash x1 double dash x2 dash x2 double dash must be greater equal to 0. Okay, so the non-negativity restriction are satisfied here. Now to form this system of linear equation in the form of LPP, here we introduce two artificial variables. Let the artificial variable are x3 and x4. Okay, and we let an auxiliary objective function as we write here max z, this is equal to 0 x1 dash plus 0 x1 double dash plus 0 x2 dash plus 0 x2 double dash minus x3 minus x4. We let this type of objective function because we apply here two-phase simplex method. Okay, so the coefficient of artificial variable are -1 and the constants are given by x1 dash minus x1 double dash plus x2 dash minus x2 double dash plus x3 plus 0 x4, this is equal to 1. Okay, this is the first constant and we introduce x3 as the artificial variable in the first constant. And the second constant is given by 2 x2 dash minus 2 x2 double dash plus x2, this is x1 dash, this is x1 double dash, and this is x2 dash minus x2 double dash plus 0 x3 plus 0, this is x4, this is equal to, this is given by equal to 4. Okay, and with xi dash greater equal to 0 for all I and xi double dash greater equal to 0 for all I and x3 x4 greater equal to 0. Okay, now we make the first simplex table of phase 1 as. Now we fill the table from the given problem as. We first fill the column of B, this is 1 4, this is 1 4, and we write in the first row, this is 1, this is -1, this is 1, this is -1, this is 1, this is 0, and the second row is 2, this is -2, this is 1, this is -1, this is 0, this is 1. Okay, and clearly the standard basis is 1 0 and 0 1, so the vector a3 and a4 are in the basis. So we write here a3, this is the first standard basis, and a4, this is the second, that is 0 1, and the corresponding basic variable are x3 and x4, and the corresponding cost coefficient CB is given by, this is 0 0 0 0 0 0 -1 -1, so these are -1 and -1. Now we find out all the net evaluation. How can find the net evaluation? -1 into 1, this is -1, -1 into 2, this is -2. So -1 plus -2 minus 0, this is Cj, so it is given by minus 3, and clearly this is given by 3, right, and this is given by minus 2, this is given by 2, this is 0, this is 0, okay, and the most negative net evaluation is minus 3. So the vector a1 dash is incoming vector. It introduced in the basis. Okay. Now find the mean ratio. What is the mean ratio? Mean ratio is 1 by 1. This is 1, and 4 by 2. This is 2. So this is minimum. We write here. This is minimum, and clearly this vector a3 is the outgoing vector. So we here give the symbol of outgoing, and this is key row and this is key column, and so this is key element. Okay, so we go to the second simplex table. In second simplex table, we fill the basis vector first, that is the vector b. Here a1 dash is incoming and a3 is outgoing. So here we replace a1 dash in place of a3, and a4 remains same. So the variable corresponding to the basic vector is x1 dash and x4. Okay, and we write a1 dash. This is a1 dash means the first element is 0, and this is minus 1. This is zj minus cj. Okay, and since key element is 1, so the first row remains unchanged. Okay, that is the operation is r1 dash. This is equal to r1, and we write the first row as similar as above. This is 1, this is 1, this is minus 1, this is 1, this is minus 1, this is 1, this is 0. Okay, and the second row is the operation is given by r2 dash. This is given by r2 minus 2 r1 dash. Okay, then this element must be 0 by this operation. So we get this element is 0, and this is 4 minus 2 into 1, this is 2. Okay, and minus 2 minus this is 0, and 1 minus 2, this is minus 1, this is also minus 1 minus 2 into 1, this is equal to 1, and this must be minus 1, this is 1. Okay, and we can drop the calculation of this column vector, because a3 is outgoing vector, and since a3 is artificial vector, so we can drop the calculation of this column, and we write this column as empty column. Okay, right, like this. Now we calculate the net evaluation zg minus cj, which is given by, this is 0, this is clearly also 0, and this is 1, this is also minus 1, and this is empty, and this is given by 0. Okay, so most negative is minus 1, so this is incoming vector, that is a2 double dash is incoming vector. And now we find the mean ratio. What are the mean ratio? The mean ratio is 1 by minus 1, it cannot be divided, so we cannot find the mean ratio because this is negative, and the mean ratio of this is 2 by 1, so 2, this is minimum. Only one element, so this is minimum, and clearly this element the key element. And it says that the a4 vector is outgoing vector. Okay, this is the outgoing vector. So we draw the third simplex table as, since a4 is outgoing vector and a2 double dash is incoming vector, so we write in place of a4 this is a2 double dash, right, a2 double dash, and the first vector is a1 dash, this is unchanged, and the first coefficient are 0 0 because this is 0 and this is also 0. Now corresponding the variable x1 dash and x2 double dash, right? And since here also the key element is 1, so the operation of this row is remains same. This is given by r2 dash, this is equal to r2 itself. Okay, so we write the second row as above, that is 2, this is given by 0, this is also 0, this is minus 1, this is 1, this is vacant, and this can be also vacant because this is the artificial vector and this vector also be removed from the basis. So we can left these two vector without calculation by giving a cross sign. Here we also give a cross sign. Okay, this means we left this column without calculation. Now this is the key element and it must be equal to 0 because this is 0 1, so this is the standard basis. So the operation of the first row is given by r1 dash, this is equal to r1 plus r2. Okay, and the value by the operation is given by 1 plus 2, this is 3, 1 plus 0, this is 1, minus 1 plus 0, this is 0, so this is minus 1, and this is 1 plus minus 1, this is 0, and minus 1 plus 1, this is also 0. Okay, now we calculate the net evaluation, and net evaluation gives this 0 0 0 0 because the cost vector is 0 here. Okay, and it is clear that all zj minus cj greater equal to 0, so optimal condition reached, optimal condition satisfied. Okay, and optimal solution is given by x1 dash, this is equal to 3, and x2 double dash, this is equal to 2. Okay, but we cannot write the solution in this type. We write the original variable one by one. The first original variable is x1 dash, this is equal to 3 from the table, this is x1 dash. Okay, x1 double dash is not in the table, so we write it is 0. x2 dash, this is also not in the table, so we write it is also 0, and x2 double dash, this is equal to 2. Okay, this is the solution by simplex method. Now the solution of the original system is given by x1, this is equal to x1 dash minus x1 double dash, so this is 3 minus 0, so this is 3, and x2, this is given by x2 dash minus x2 double dash, this is given by 0 minus 2, so this is minus 2, right? So the solution of the system we get by simplex method as x1 equal to 3 and x2 this is equal to minus 2. Okay, this is the complete method and the complete solution of the system of linear equation by simplex method. Thank you for watching.